Are you facing frustrating segmentation faults while debugging your shared library? You're not alone. Today, we're diving into a common issue with libc-2.23.so and how to resolve it. I completely understand how annoying it can be when your code crashes unexpectedly. Segmentation faults can be particularly tricky, especially when they occur in shared libraries like libc. You're definitely in the right place to get some help. Let's take a closer look at the specific issue at hand. One user reached out for help debugging a shared library, specifically libc-2.23.so. They noticed repeated segmentation faults in their logs, and they want to know how to capture and resolve this issue. Sound familiar? Let's work through it together. So what exactly is happening here? A segmentation fault occurs when a program tries to access a memory location that it's not allowed to. In this case, the user is seeing consistent faults at a specific offset in libc-2.23.so. Let's figure out how to troubleshoot this. And stick around. By the end of this video, you'll have a clear understanding of how to debug these segmentation faults effectively. To begin resolving the segmentation fault in the shared library, the user should first ensure that they have the necessary debugging tools installed. This includes GDB, the GNU debugger. Next, the user should run the application under GDB to capture the segmentation fault. This can be done by starting GDB with the application executable. When the segmentation fault occurs, GDB will pause execution. The user can then use the backtrace command to see the call stack at the time of the fault. To further investigate, the user can examine the variables and memory state at the time of the fault. This can be done using the print command in GDB. Finally, if the user identifies a specific line of code causing the issue, they can modify the source code and recompile the application to test the fix. Interestingly, the user found that the offending line was just a comment in the source code. This suggests that the issue might not be directly in the code itself, but could be related to how memory is being managed in the application. Fun fact: did you know that segmentation faults are often referred to as Segfaults in the programming world? It's a term that strikes fear into the hearts of many developers. Now, let's look at the answers provided by other users. An alternative approach suggests that the segfaults you are experiencing are likely due to heap corruption, particularly since they occur in the compiz application. The user recommends filing a bug report for this issue. Additionally, the user points out that debugging with GDB may not be effective in this case. Instead, they suggest using Valgrind to capture the issue, as GDB might not catch the segfault if compiz forks helper processes. Here's a pro tip. Always ensure that your memory management is solid. Use tools like Valgrind to check for memory leaks and issues that could lead to segmentation faults. And there you have it. With these steps, you should be well on your way to resolving those pesky segmentation faults. If you found this video helpful, please subscribe for more troubleshooting tips and tricks.